Hello, we are working on lesson 2-4, graphing a function rule. We have some vocabulary, representation, which is just a way of saying that there are various ways to display or describe information. And some of those ways are tables, ordered pairs, graphs, and equations. One thing that's not up there is words. Okay, we can get a story problem or a word problem, and that also is a way to describe information. We take that information, we could put it into one of the ones listed: table, order, pairs, graphs, and equations. We have two other vocabulary words: continuous and discrete. A discrete graph is one in which you cannot have any value for on the x-axis, meaning that you can't have numbers between, say, 1 and 2. You can only have 1, or you can only have 2. You can only have 1, and you can only have 2. You can only have 3. And so if you had 1.5 on the x value, that would be continuous, because, or 1.25. If you can have any value between 1 and 2, then you would have a continuous graph. That sounds a little bit complicated. So when we get to some of the word problems, I will explain it a little bit better, and to where you'll be able to identify whether a graph should be continuous or discrete. And you'll notice the difference between continuous and discrete is discrete is just plotted points, whereas continuous is you connect those ordered pairs together. Okay. All right, so we're going to go down to our example, and all we're going to do is create a table and determine what our ordered pairs are and graph an equation. Okay, so let's look at this equation here. We have x here, we have our whole equation here, y, and then we put x and y together as an ordered pair. Now, we're just going to come up with some random numbers for x. They don't give them to us. We're just going to create our own so that we can graph that equation. Some of you might be saying, well, I can graph that equation without the table. And yes, I understand that. That's great. But we also want to learn how to create a table from an equation and practice that. So what I like to do with my x values is always have some negatives, some positives, and 0. So an easy way to do that is to say I'm going to have an x value of -2, -1, 0, 1, and 2. And if I have a simple equation, this is what I do. If I have an equation with fractions, I do something a little bit different, and we will get to that in a little bit. All right, so what I'm going to do now is I'm going to write out my equation and plug the x value I chose into the equation where x is and solve for y. So this is what this looks like. Y equals -2 times my x value of -2 plus 1. Okay, and then I solve this. Okay, -2 times -2 is a +4, and then I add 1 to it, and I get 5. So my y value is 5. And then when I write that as an ordered pair, my x comes first and then my y, so I write it as -2, 5. And we're going to go throughout the whole table like that. Okay, so if you're catching on, you know what to do. Go ahead and move forward. If not, go ahead and work along with me. So my equation is y equals -2. This time my x value is -1. And then I add 1. And -2 times -1 is 2, and 2 plus 1 is 3. So then my ordered pair is -1, 3. Let's plug in 0. Y equals -2 times 0 plus 1. And now I'm going to solve that. -2 times 0 is 0, plus 1 is 1. So my ordered pair here is 0, 1. Okay, I want you to go ahead and finish 1 and 2 on your own, and then we'll come back and graph those plotted points. Okay, so this is the table when it is completed. And now what we're going to do is we're going to plot our ordered pairs on the graph, and we are going to see, this is a linear equation, so we should form a straight line. If it doesn't form a straight line, you may have plotted one of your points wrong. So we're going to go -2, 5, -1, 3, 0, 1, 1, -1, and 2. Oops. Oh, 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 I made a mistake. That did not look right. So this should be a -4 right here. -4 plus 1 is a -3. So if you're in my class watching this, this is typical Mrs. Weatherman. I'm constantly making these mistakes. So we have a -3 here. And you know, I could tell that I made a mistake because my line was not going to be straight when my ordered pair wasn't going to go down into a straight line. So 2, -3. And now we can go ahead and draw our line. And there you go. Example 1. Okay, let's go ahead and move on to page 2. We have another problem. This time we have a fraction. And so we need to be a little bit creative when we have fractions. We don't typically like to graph decimals. It doesn't mean that we ever won't, but if we don't have to, then why do it, right? So the points that I'm going to choose for X are going to be multiples of 3. Okay, so I'm going to start off with, well, I'm going to put 0 in here in the middle. And so I know that -3 is divisible by 3, and I know that -6. So I'm going to do -6, -3, 0, 3, and 6. And so then that way, when I plug those into the equation, that fraction will be cleared. So let's go ahead and do a couple of these. Y equals 1/3 times a -6 minus 1. So 1/3 times a -6 gives us a -2. -2 minus 1 gives us a -3. And then our ordered pair is -6, -3. For those of you who didn't understand how I got the -2, this is 1 times -6 is -6. And then over 3, and that it gives us a -2. If it makes more sense, I can write it up here. I have 1/3 times -6, and I could either cross cancel or multiply straight across. Those who don't know how to cross cancel, then if I were to do that, it might not make any sense. So I'm just going to go ahead and multiply straight across. 1 times -6 is -6. 3 times 1 is 3. -6 divided by 3 is a -2. And so that's how I got -2 down here. And you'll do that with every problem. Okay. So y equals 1/3 times -3 minus 1. So 1/3 times -3 is a -1. -1 minus 1 is -2. And we can write our ordered pair out as -3, -2. All right, I would like for you to go ahead and try the rest on your own and graph it, and then we'll come back together and check our work. Okay, you can go ahead and check your table and your graph. Make sure that you did it correctly. And if not, you want to go back and maybe check your work over in the table. Make sure you have the correct ordered pairs, maybe see where some calculations went wrong. Okay. All right, we are going to move down to word problems, which I know is everyone's favorite. Okay. Now, the good thing about this word problem is that the equation is given to you, so you don't have to come up with the equation, but you do have to write a correct graph. All right. So, and we're going to worry about this at the bottom in a little bit. All right, we have a function rule that represents the total weight in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 feet cubed, what is a reasonable graph of the function rule? Notice the word reasonable. Okay, this has to make sense. So the C stands for the cubic feet that it can carry. And it says here that the capacity is about 200 feet cubed, which means that that's the maximum it can hold. So the truck can hold anywhere between 0 cubic feet of concrete and 200 cubic feet of concrete. So I know that I want my table to go from 0 to 200. So I'm going to write that here, 0, 200. Now remember, I said that I like to have negatives, zeros, and some positives. Well, in this case, you can't have negative cubic feet. So we're not going to include negative in our table. All right. Now, I have 1, 2, 3, 4, 5. I have 5 boxes. I go up to 200. I could divide that by 5. And I can go by 50s. Okay. So 0, 50, 100, 150, 200. Now this is reasonable. 0, 1, 2, 3, 4, 5 is not reasonable because it doesn't show us what the actual maximum capacity or the weight is going to be when it is at its maximum capacity. And that's what we want to see. What is the the lowest it can weigh, and what is the highest that it can weigh? What's its minimum? What's its maximum? Okay, that's what we want to see with a real world problem. So we're going to do with this equation what we did with the others. So we're going to go ahead and write this out. W equals 146 times 0 plus 30,000. Now this one's pretty easy, even though it has big numbers, because 146 times 0 is 0 plus your 30,000. Okay. And so our W is going to be 30,000. Now I didn't leave space to write the ordered pair like I did up here. But that's okay. We know that our ordered pair is going to be 0, 30,000. Okay, let's go ahead and do this next one. W equals 146 times 50 plus 30,000. And yes, you're going to have to do some by the hand calculations. So we're going to multiply 146 by 50. And if you remember, oops, I lost my pencil here. There is an easy way to do these calculations. So down here, I'm going to put 140, write down 146 times 50. I'm putting my 0 off in La La Land, and then I'm just bringing it down. So I don't have to multiply 0, 0, 0, and then add a 0. And so here we go. 5 times 6 is 30. 5 times 4 is 20, plus 3 is 23. 5 times 1 is 5, plus 2 is 7. And so for this part right here, 146 times 50, we get 7,300 plus this 30,000. So when you add those together, you get 37,300. All right, I want you to go ahead and finish out the table. Wait to do the graph with me. I want to show you how to do a real world graph, or a graph that represents a real world situation. Okay. Okay, check your graph, make sure that it is correct. And then we are going to move on to creating, or check your table. We're going to move on to create our graph. So when you make a graph representing a real world situation, you want to label your X and Y axis. You want to give them both increments and you want to give your graph a title. Those are some key characteristics of a proper graph. So I am going to give my, and listen, your title could be whatever you want as long as it represents the situation. So I'm just going to give it the title, concrete truck capacity. Okay, doesn't have to be anything fancy. Now in our table, the cubic feet represents our X and the total weight represents our Y. So on the X axis, we're going to have the amount of concrete. And we want to put the units here, and our units are feet cubed. Okay. And then on the y-axis, we're going to have total weight in pounds, or just we can put weight and put pounds here. Okay. The next thing that you want to do is you want to put increments on your x and y axis. So let's look here. We have increments going from 0 to 200. So I like to look at my graph, see how much space I have. And let's see, if I went by 25s, 25, 51, oh wait, 25, 50, 75, 1, 2. I could go by 25s. Maybe I could go by something smaller. Let's try 20s, 20, 40, 60, 81. I could go by 20s. Actually though, if I think about it, 25s might be better because these are divisible by 25. So I am going to go by 25s. So we always start at 0 and I turn my graph sideways to do my increments. So we're going to go 25. Okay. Now let's do our increments for our y-axis. Now our y-axis increments go all the way to almost 60,000. So I think what I'm going to do is I'm going to go up by 5,000s. So this one would be 5,000, 10,000, 15, 20, 25, 30, oops, 35, 40, 45, 50, 55, 60. Okay, what I could have done to make this easier is just skipped the 5,000s and just skipped a line into 10,000, skipped a line 20 and stuff like that. That you can do that. Another thing that sometimes people do is they put in parentheses in thousands here or in 10,000s here. And so then they would just put 5, 10, 15, 20, 25, 30. So that's a shortcut way of doing it, or a shorthand way. All right, now what we're going to do is we are going to graph our results here. The concrete truck at 0 is 30,000 pounds. Before we graph that though, what does this actually mean? Okay, the 0. The 0 represents that there's no concrete, no cubic feet of concrete in the truck. And what that means is the truck without concrete weighs 30,000 pounds. So it weighs 30,000 pounds before you put any concrete in it. If it had 50 cubic feet of concrete, then the truck would weigh 37,300 pounds. And that's how you would read this. So let's go ahead and plot our points. We have 0, and then we're going up to 30. And then we have 50, and we're going to go up to about 37,300. It's about in between here. And then 100 and close to 45,000. And then 150, which is about 52,000. And then 200, which is close to 60,000. Okay, and now we can draw our line. And this is linear. It is changing at a constant rate. Okay, so that's what that one should look like. Okay, now we're going to come down here to something that is brand new to us. Intervals of C. Okay, let's look. C is on the x-axis. It represents the amount of concrete. When we want to know the intervals, we want to know what are the possibilities when it comes to the amount of concrete that can be in the truck. Well, based on our table, concrete can be anywhere between 0 and 200. Okay, well, can it be 1 cubic feet? Sure. Can it be 0.1 cubic feet? Sure. Could it be 0.1234 cubic feet? Sure. And what that means is that measurements can be in finite increments. It can be in decimal fraction form. So it truly can be anywhere between 0 and 200 and every single number in between. So that is called a continuous graph. So at the beginning, I told you I would explain in a little bit of a better way what a continuous graph means. So going back to the graph we just did, it could be anywhere between 0 and 25, anywhere between 0 and 200, any number at all on the scale. So how do we write that? Well, we know that the amount of concrete can be greater than 0, but it can't be less than 0. So the concrete can be greater than or equal to 0. But the concrete also cannot be more than 200. So we would write that as less than or equal to 200 because it can be 200, but it can't be greater than 200. And so this is how you would write an interval for a continuous graph. But we're also going to do this for W. Can the weight be anywhere in between 30 and 59,200? Well, yes, because weight can be any value between that 0 and 1 or that 0.1 or whatever. So we're going to write this interval in the same way that we wrote this one. So the weight of the truck starts at 30,000. So it can be 30,000 or more. Okay. But it cannot exceed 59,200. So it would have to be less than or equal to 59,200. Okay. And so that's how you would write intervals for a continuous graph. And then right here, I want you to write continuous graph. And the reason is because those units right here can be any value between 0 and 200. Okay, let's go ahead and move on to page 3. We have more word problems. Now we have to create our own equation. Once we create your equation, I'm going to have you fill out the table and complete your graph on your own. Attempt your intervals, and then we're going to check back. But first, let's come up with the equation. So it says that a hotel charges $90 per night for a room, and they charge an additional $8 for each person staying in the room. So right off the bat, if you're going to rent a room, it's $90. Then they're going to tack on a fee of $8 per person. Each room has a maximum capacity of 5 occupants. Assuming the occupants are staying only one night, write a function for this situation where P is the number of people in a room and C is the total cost. Okay, so we know that there is going to be this fee of $90. It's a one-time fee. Okay, so that's going to represent the B, the y-intercept in our slope-intercept equation. So this is our B. And then we know that it's going to be $8 per person, and P represents the person, so $8 per person. So it's going to be the 90 plus the $8 per person, and that's going to give us our total cost, which means that our equation is going to be C equals 8P plus 90. We want to use the variables that were given to us. We want to use P, that stands for the number of people, and we want to use C, total cost. So in this situation, P is our independent variable because the total cost depends on how many people are going to be in the room. So if the cost depends on the people, the cost is the dependent variable. The dependent variable is our Y. So we have P and C, and then we're going to write our ordered pairs, P, comma, C. So now we need to find what our increments of people are. What should our increments be? I want you to think about this. And then I want you to listen to this sentence. Each room has a maximum capacity of 5 occupants. Well, we can't have more than 5, but we can have 5. So I know that the maximum is going to be 5 down here. Now, does it make sense to put 0 in there? No, because if no people are going to be in the room, why would you even rent it? Okay. I mean, you could, but why, right? So we're going to come and we're just going to fill this out as 1, 2, 3, 4, 5. Now, what I want you to do is I want you to finish out this table. And then I want you to maybe label the graph how you think it should be. And then we're going to come back and compare what we have. All right. So go ahead and do that now. Okay. So here we are. I want you to check the table, check your graph, make sure you have it labeled correctly with your X and Y axis and increments. Now down at the bottom, I did skip a line. So yours may look a little bit different if you didn't skip the line, but that's okay. So check that overall. If you need to pause the video, go ahead. But moving on, you'll notice that I didn't draw a line through my points. The reason being is this is considered a discrete graph because you cannot break your increments up that are on the x-axis. To determine if it is discrete or continuous, you have to look at the x-axis, okay? We cannot have half a person in the room. It doesn't make sense, right? It's not reasonable. Now, some may kind of try to joke around and figure out, like, is there a way that we could do that? Okay, we're not. So that means that there can only be one person. There can only be 2 people. There can only be 3 people, or there can only be 5 people, okay? Or 4 people. So this is considered a discrete graph, right? So I'm going to write discrete down here. I'm answering this question. And when you have a discrete graph, your intervals are written differently, okay? They're written like this. I'm going to do this little bracket, and I'm going to put in all the possible values for P that we could have. 1, 2, 3, 4, 5. And why didn't I go beyond 5? Well, because it says the maximum capacity is 5 occupants, so I can't go above 5. All right. Now I'm going to do the same thing for intervals. Our cost, even though money can be any value, it's not going to be more or less for one person here. It's going to be exactly $98. Okay. So when we do intervals here, and we're excluding tax, we'll have 98, 106, 114, 122, and 130. Okay. So that's how you would write the intervals for a discrete graph. So over here, let's see, what did I do? I want you to write discrete graph. Okay, there we go. All right, let's go down to example 5. Now, what I would like for you to do is I want you to read this, and I want you to come up with what the equation is for this situation. So I'm going to give you a minute to do that, and then we'll come back and check. This is what you should have gotten for your equation. The total cost for strawberries is $4.50 per pound. That's what that means. So we don't have an additional cost to that. So what you're going to do now is we're going to fill this, the increments out for the weight. And we want to kind of be creative here. So if you did not want to have to deal with decimal numbers, then we would want to multiply 4.5 times an even increment. Then that way we'll end up with whole numbers. So what do I mean by that? Well, we can start with 0. If you buy no strawberries, you pay nothing, right? And then if I buy 2 pounds, that is going to look like this. C equals 4.5 times 2. 4.5 times 2 is 9. So our cost is $9. Here it's going to be 0 because if I buy no pounds of strawberries, then I pay nothing. So our ordered pair here is 0, 0, and our ordered pair here is 2, 9. Okay. So it makes sense in this situation to just do even increments. You don't have to if you don't want to, but you can. And so then I'm going to go 2, 4, 6, 8. Okay. So go ahead and finish this table, create your graph, and then hold off on the intervals again. You can try to determine if it is continuous or discrete if you'd like. If you want to take a shot at the intervals, you can. All right. Okay. So I'm going to pause the video and give you a minute to do this. So this is what I got for my table and my graph. I added 10 at the bottom. I don't know why. I guess because my graph was able to go up to 45, so why not? I did go by 1s on the x-axis. I went by 3s on the y-axis. Some students would have maybe gone by 9s, but really we want to choose the smallest increments we can possibly go on the graph that we're given. So that is why I went by 3s. This is a continuous graph because weight can be any value, any increment between 0 and 1. So you could have decimals and fractions mixed in there. Okay, because of that, then our weight, the weight for our intervals, it's going to be 0. It can't be negative, but it can be greater than, or it could be equal to 0 if you don't buy any. But what is the maximum pounds you could buy of strawberries? There is none. So we can do, it has to be less than or equal to infinity. And the weight is the same thing. The weight is 0 if you buy no strawberries. And if you buy an infinite number of strawberries, you're going to have an infinite amount of weight. Okay. So that is this graph, example 5, and we're going to move on to the last set. So these last 2 problems are just ones that are a little bit different, and I saw some examples like this on the homework, so I thought I would throw them in there just to get you familiar with non-linear equations. So let's look at this one. We're going to go ahead and fill out our table based on what we have. We're just dealing with an x and y equation, so there's not going to be any labeling on your graph. All right, so let's fill this up. And this is going to go back to the beginning where I want some negatives and I want 0 and I want some positives. So in this table, we're going to go -2, -1, 0, 1, and 2. And we're just going to plug those in and solve. Now we're dealing with an absolute value problem, and you may or may not have done absolute value this year. I know my class hasn't. So let's see what this looks like when I plug the absolute value in there. So I'm going to plug in a -2 right here. Do this. Okay, so what is this? What is actually happening here? And I'm going to erase this a little bit just to give me some space. What is the absolute value of -2? The absolute value of -2 is 2 because it's 2 units from 0 on the number line. Okay, so 2. And then we're going to subtract our 4 and we get -2. So when X is -2, Y is -2. And so our ordered pair is going to be -2, -2. Now, if you don't understand that absolute value, then you may want to come into help class and I can go over that with you in a little bit more detail. We do assume when we get to this lesson that you already know about absolute value. But like I said, if you need help, come to help class. So let's go ahead and do the next one. We have Y equals the absolute value of -1 minus 4. The absolute value of -1 is 1 because it is 1 unit from 0 and units are not negative. And then we subtract 4 and we get a -3. And now we have Y equals the absolute value of 0. The absolute value of 0 is 0. And 0 minus 4 is -4. Okay. Now we have Y equals the absolute value of 1. The absolute value of 1 is 1 because it's 1 unit from 0 on the number line. And we end up with a -3. And our final one, Y equals the absolute value of 2. The absolute value of 2 is 2. You might know what I'm going to say because 2 is 2 units from 0 on the number line. Okay. If I'm going too fast, go ahead and pause the video and try to do some of this on your own. Now I'm going to plot my points. So I have -2, -2, -1, -3, 0, -4, 1, -3, and 2, -2. So you're going to notice this is not a straight line. That's okay. Some graphs aren't going to be a straight line. So we're just going to connect these. And here is a graph in the shape of a V. Okay, let's move on to the last example and then we'll be finished with lesson 2-4. We're going to go ahead and fill this out. You might be a little bit more familiar with squaring units or squaring numbers. So again, I'm going to use -2, -1, 0, 1, and 2. And I'm just going to plug in what I have. So I'm just going to fill out my chart. It'll go by faster. Okay, and then we're going to have -2 squared, -1 squared, 0 squared, 1 squared, 2 squared. Okay, so when we do this, -2 times -2 is 4. 4 plus 1 is 5. -1 times -1 is 1. 1 plus 1 is 2. 0 squared is 0. 0 plus 1 is 1. 1 squared is 1. 1 plus 1 is 2. And so on. So 2 and, oh wait, no. I'm sorry. I put 5 over here. I was thinking 4 plus 1 is 5. Okay, and then we have 5. So now we can write out our ordered pairs and graph our, it's going to be something called a parabola. You learn a lot about those later. Okay, so let's plot our points. -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. You see that pattern here, 5, 2, 1, 2, 5. And then when you draw this, this is a parabola. I know that because it has an x squared. Parabolas will have an x squared that started off. And this is more of a U shape, not a V. Okay. Great, that was a lot of information in one lesson. So if you need help with any of this, please come to help class. And this concludes our notes for lesson 2-4.